Welcome back to Global Works TV, where we explore the remarkable world of industrial timber processing. Today, we're taking you on a fascinating journey through some of the world's most advanced sawmills and wood processing facilities, starting in the pristine forests of Estonia. The journey begins at the log yard, where massive timber trucks deliver freshly harvested logs. Here's where things get interesting. Toftan 2 uses an automated sorting system that would have seemed like science fiction just a generation ago. Each log passes through a sophisticated scanning station equipped with 3D laser technology and X-ray sensors. These sensors measure diameter, length, taper, and even internal defects like knots and rot. The computer system processes this data in milliseconds, determining the optimal cutting pattern to maximize yield. It's like giving each log a complete medical examination before surgery. Once sorted, logs move via chain conveyors to the debarking station. The ring debarker, a powerful machine with rotating arms fitted with hardened steel teeth, strips away the rough outer bark in seconds. This isn't just for aesthetics. Removing bark prevents premature dulling of the expensive carbide-tipped saw blades downstream and eliminates contamination in the final product. The bark itself isn't wasted. It's collected and used as biomass fuel to power the mill's heating systems, a sustainable practice that old-timers would appreciate. Next comes the heart of the operation, the primary breakdown line. Toftan 2 employs a quad bandsaw configuration, meaning 4 large bandsaw blades working in tandem can slice through a log in a single pass. Each blade is over 30 feet long and just a few millimeters thick, spinning at tremendous speeds. The log positioning system uses servo-driven rollers that rotate the log with precision, ensuring each cut follows the grain pattern identified by the scanner. This is where craftsmanship meets technology. The system makes decisions similar to what a master sawyer would have made by eye, but with computer-aided accuracy. As the cant, the squared-off center section, continues down the line, smaller gang saws and edgers trim it into dimensional lumber, 2x4s, 2x6s, and various other standard sizes. The edger saws, positioned on both sides, remove the rounded edges, creating clean, square boards. What's remarkable is the speed. A single log can be completely processed into sorted, stacked lumber in under 2 minutes. The final sorting system uses a combination of moisture meters and strength grading technology. Remember the old days of stamp grading? Today's systems use acoustic sensors that actually listen to the wood's internal structure, rating its strength properties without destructive testing. Boards are automatically diverted to different stackers based on grade, moisture content, and dimension. High-grade, kiln-dried lumber destined for furniture making goes one direction, while construction-grade material heads another. It's an orchestra of efficiency that would have taken dozens of skilled workers to accomplish in decades past. Now let's shift gears to a more traditional side of the timber industry. China's Firewood company represents a business that's been essential to human comfort since our ancestors first tamed fire. While modern heating might dominate our homes, there's still something special about the warmth of a wood fire, and millions of Americans agree, whether for heating, cooking, or ambiance. The process starts with log receiving and rough cutting. Chinooz uses heavy-duty hydraulic chainsaws mounted on processing heads that can handle logs up to 3 feet in diameter. These aren't your grandfather's chainsaws. They're industrial machines with 60-inch bars powered by diesel hydraulic systems. The processor grabs a log, measures it, and cuts it into 16-inch sections faster than you could mark the measurements by hand. Here's where Chinooz really shines: their automated firewood splitting line. Traditional firewood production meant back-breaking work with mauls and wedges. Chinooz employs a multi-wedge hydraulic splitter capable of producing over 10 tons of splitting force. What makes this system clever is its adjustable splitting pattern. Smaller rounds get split into 2 or 4 pieces, while larger diameter logs are split into 6 or 8 pieces for optimal drying and burning. This splitter uses a sensor system to detect log diameter and automatically adjust the splitting configuration. It's a beautiful piece of engineering that combines pneumatic controls with hydraulic power. The wedges are arranged in a radial pattern, and when the log is pressed into them, it splits along natural grain lines into perfectly sized pieces. After splitting, wood moves to the drying yard. Chenews uses both traditional air drying methods, stacking wood in covered sheds with excellent airflow, and modern kiln drying for premium customers who want immediately burnable wood. Their kilns are massive insulated buildings where temperature and humidity are precisely controlled. The drying process reduces moisture content from around 45% in fresh-cut wood to below 20%, the ideal range for efficient burning. The final step is packaging and loading. Firewood is bundled, stacked on pallets, and loaded onto delivery trucks. It's an operation that honors tradition while embracing efficiency, producing thousands of cords annually while maintaining the quality standards that serious wood burners demand. From Estonia, we travel south to Poland, where Paged Plywood SA has been crafting premium plywood since 1951. For those who remember the post-war building boom, plywood was the miracle material that helped rebuild cities and create affordable housing. Today, Paged continues that tradition with technology that transforms humble logs into engineering-grade panels. The process begins with log conditioning. Unlike softwood sawmills, plywood production requires logs to be heated in massive steam vats. This 24-hour soaking process, conducted at carefully controlled temperatures around 140 degrees Fahrenheit, softens the wood fibers and makes the logs pliable enough for veneer peeling. The rotary lathe is where magic happens. Picture a massive mechanical pencil sharpener, but instead of shavings, you get continuous sheets of wood. The debarked log spins against a razor-sharp knife blade that's over 8 feet long. As the log rotates, a thin ribbon of veneer, typically 1/16 to 1/8 inch thick, peels away in one continuous sheet. These veneer ribbons travel through clipping stations where guillotine knives cut them into precise sheets. Here, trained operators monitor quality, removing defective sections with knots or grain irregularities. These aren't discarded. They're used for inner plies or processed into other products. Nothing goes to waste. The assembly process is fascinating. Sheets are dried in massive roller dryers, then graded and sorted. Paged's computerized layup system stacks veneers with alternating grain directions. This cross-lamination is what gives plywood its legendary strength. A 5-ply panel might use premium birch faces with beech cores, each layer precisely positioned. The gluing process uses phenol formaldehyde adhesives applied by roller spreaders, ensuring even coverage. Then comes the hot press, where massive hydraulic plates, some as large as 20 by 10 feet, compress and heat the stack to 300 degrees Fahrenheit under pressures exceeding 200 psi. This transforms the glue and wood into a solid, unified panel stronger than the individual pieces. After pressing, panels are trimmed on precision saws, sanded smooth on multi-head sanders with progressively finer grits, and inspected. The final products range from furniture-grade panels with flawless faces to marine-grade plywood that can withstand years of water exposure. It's a remarkable transformation from round logs to precision-engineered panels. Crossing back to North America, Freeman lumber represents the finest traditions of American sawmilling combined with cutting-edge technology. Located in the heart of timber country, Freeman has been processing logs since the days when lumber camps were seasonal operations and river drives moved logs to mill. Today, they're a model of modern efficiency while maintaining respect for the resource. The operation begins with log sorting by species, size, and quality. Freeman's log yard spans several acres, organized like a well-planned library. Logs arrive from sustainable forest operations, already bucked to optimal lengths, typically 16, 20, or 40 feet depending on end use. The log deck feeding system uses a combination of hydraulic loaders and mechanical debarkers. Their debarker is a ring-style unit with rotor arms that can process logs up to 48 inches in diameter, stripping bark while minimizing wood fiber loss. Freeman's primary breakdown saw is an impressive double-cut band mill head rig. This traditional design, though modernized with computer controls, has been the workhorse of American sawmills for generations. The bandsaw blade itself is a continuous loop of high-carbon steel, typically around 40 feet in circumference and 9 inches wide, studded with carbide-tipped teeth. These blades cost several $100s each and must be precisely tensioned and maintained by skilled saw filers, a craft that's been essential to quality sawmilling for over a century. Here's where experience meets innovation: the Sawyer's Station. While computers handle log scanning and optimization, Freeman still employs master sawyers who oversee the cutting decisions. These craftsmen, some with 4 decades of experience, read grain patterns, identify defects, and make real-time adjustments that computers might miss. They understand that each log is unique. 2 Douglas fir logs from the same stand might require completely different cutting strategies to maximize yield. The log positioning system, called a log turner, rotates each log to optimal cutting orientation. The first cut, called the opening face, establishes reference surfaces. Subsequent cuts peel boards from the log-like pages from a book. The cant that remains after initial breakdown moves to the gang saw, a machine featuring multiple parallel blades that can slice it into several boards simultaneously. Freeman's resaw line handles the dimensional cutting. Here, boards are edged to remove wane, that rounded edge containing bark, and ripped to standard widths. Their edger uses twin circular saws on adjustable carriages, computer-controlled to maximize value from each board. A clear, knot-free Douglas fir board, destined for finished carpentry, is worth significantly more than structural-grade lumber, so these decisions directly impact profitability. The trimmer saw station is where boards reach final length. Multiple circular saws, spaced at standard intervals, can cut a board to length while removing defect sections. Optical scanners identify knots and defects, and the system determines optimal cutting positions in microseconds. What results might be one 16-foot clear board, or perhaps a 12-footer and a 4-footer, depending on defect location. Grading and sorting follows. While automated systems handle much of this, Freeman still employs experienced lumber graders, who verify quality classifications. These professionals can identify the subtle differences between select structural and number 1 grade at a glance, distinctions based on knot size, slope of grain, and other characteristics defined by grading rules established generations ago. The drying process is crucial. Freeman operates both air-dry sheds and modern kiln facilities. Their kilns are engineered marvels, building-sized chambers with sophisticated controls managing temperature, humidity, and airflow. The drying schedule for Douglas fir might run 10 to 14 days, carefully controlled to prevent checking, warping, or case hardening. Moisture meters verify that lumber reaches target levels, typically 15 to 19% for framing lumber, or 6 to 8% for finish grades. Final processing includes planing operations for premium products. Freeman's planers smooth rough-sawn lumber to precise dimensions with glass-smooth surfaces. These four-sided planers can handle boards at remarkable speeds, with multiple cutting heads removing material to tolerances of a few thousandths of an inch. The finished lumber is sorted, bundled, and wrapped for shipment. Freeman's products supply everything from home construction to boat building, furniture making, to timber frame construction, continuing traditions while meeting modern building codes and standards. Our final stop takes us to Salat Valley Sawmill, where traditional timber framing techniques meet modern milling precision. If you've ever admired an old barn with its massive hand-hewn beams and mortise and tenon joinery, you'll appreciate what Salat Valley accomplishes with Douglas fir, producing the heavy timber components for traditional post and beam barn construction. Douglas fir is the ideal choice for this application. Its tight-grained structure, excellent strength properties, and natural beauty have made it the premier timber framing species for over a century. When you walk into an old barn and see those massive beams still standing straight after 80 years, there's a good chance they're Douglas fir from the Pacific Northwest. Salat Valley's operation begins with selective log procurement. Timber framing requires large dimension, clear-grained logs. We're talking about trees that might be 150 years old, 30 inches in diameter or larger. These aren't plantation trees. They're carefully selected from sustainable forestry operations, where mature trees are harvested individually. The sawmill itself is a custom-designed operation. Their primary saw is a large circular head rig, a design that offers advantages when processing large diameter logs into heavy timbers. The saw blade, sometimes 5 feet in diameter with teeth like a shark's, spins at controlled speeds while the log advances on a heavy-duty carriage. This isn't about speed, it's about accuracy and quality. Here's what makes Salat Valley special. They're cutting timbers to exact dimensions for traditional timber frame joinery. A typical barn frame might require 8x8 posts, 6x10 beams, and 4x6 rafters, all cut to precise lengths with specific orientations to minimize cupping and twisting as the wood seasons. The sawyer must read each log, identifying the heart center and cutting around it to produce the most stable timbers. After primary breakdown, timbers move to the planing operation. Unlike standard dimensional lumber, heavy timber often receives just enough planing to reveal the grain and ensure dimensional accuracy while maintaining a slightly textured surface that's traditional and beautiful. Their 4-sided planer can handle timbers up to 12 by 12 inches, removing saw marks while preserving the wood's character. The really interesting work happens at the timber cutting stations. Traditional barn framing uses mortise and tenon joints, rectangular holes, mortises that receive projecting tongues, tenons from intersecting members. Salat Valley employs computer-controlled chain mortisers and tenoning equipment that can cut these joints with precision that rivals handwork. These machines use multiple cutting chains or rotating bits to hollow out mortises or shape tenons, following digital cutting patterns created from the barn designer's specifications. Each timber is marked and numbered corresponding to its position in the final structure. It's like a giant 3-dimensional puzzle. Every piece has its specific place. This system echoes traditional barn raising methods where timbers were cut and fitted at the mill, then transported to the site for assembly. The attention to detail extends to wood selection. Salat Valley grades each timber not just for structural integrity but for appearance. Knots are acceptable in traditional framing. In fact, they add character, but they must be tight and sound. Checks and splits are monitored. Some natural checking is expected and acceptable, but structural integrity cannot be compromised. Their finishing process includes an optional rough-sawn texture planing that gives timbers an authentic, hand-hewn appearance while maintaining precise dimensions. This technique satisfies customers who want the romance of traditional construction with modern engineering reliability. The final products leave the mill as complete barn frame packages, every post, beam, rafter, and brace cut, fitted and ready for assembly. It's a remarkable blend of old and new, using technology to preserve traditional craftsmanship, creating structures that will stand for generations, just like the barns our grandparents knew.